All right, so this is Project Buddy, and as Dr. Wang said, easy to use task manager system for workers with developmental disabilities. Um, so here's just a quick outline. Just going through the team introductions about our system design, the software and hardware are part of it, the testing, bill of materials, codes of standards, ethics, and all that. And next is the team. So my name is Stephen Owens. I'm the database design research and the team leader. One of our hardware leads is Jonathan Alanya. He is interested in embedded systems, and he's involved in the hardware. Next is Timothy A. Bear. He was interested in application development, and he worked as a software lead in the development of the app. And the next is Peter Mossman, who is interested in security and project management, and he was involved in the hardware team. So just a little bit of the project motivation and why we did it. Well, first of all, we'd like to thank Dr. Wang, Manhattan College, the Department of Electrical Engineering, and YAI and the CREATE program for helping us come up with this program, this project, and giving us the funds and the information and the help we needed to help complete the project. So first of all, is the big picture. So we're working with the CREATE program, which is a program designed to help people with disabilities of all forms, such as visual disabilities, mental disabilities, developmental disabilities. We were working with YAI, and they specifically help people with developmental disabilities, in which they try to get people with developmental disabilities jobs at common places like retail, like Target, Stop and Shop, and other places. And the common problem they were having was that these workers were not able to complete the tasks because they didn't know how. They didn't know how to communicate properly, and that they would just have they would get distracted by common things. So those are things we took into consideration when trying to solve this problem. So we wanted to make sure that the task you're using was simple, it had a web app, a Wi-Fi access, was volume sensitive and display sensitive, to just keep in mind the people we're working with, because they do oftentimes have severe reactions to sensory overload and stuff like that. Just some quick related works. The system we're using is a task manager like system that works from a web app that sends out basically tasks to the pager system. So it's just similar to that with like radio communication, emails, and cell phones. And then before we get a little bit more into the project, it's just more of the description is we wanted to create this because people that we were helping usually get jobs in these retail services, around 70%. And with automation and everything else going on, it's very hard for, we refer to them as the people we support, to keep and maintain these jobs. So the whole point of our project is to hopefully, first of all, starting with YAI, the people we support, help them get jobs and reduce the amount of unemployed people in their care, and hopefully eventually make them more independent and able to take care of themselves with a lasting job. And then just some other CREATE programs that we researched and got some motivation from: the Serve and Go from the Cooper Union. This is basically a design system. It was basically a foldable tray that hooked onto a wheelchair and allowed one of the workers at a cafe to be able to deliver food and drinks, that they weren't allowed to before because of the inaccessibility of like wheelchairs and stuff like that, and how much they could hold. So we use that. We like that project, to help out people with disabilities in the workplace. Next was the Indoor Assist at the City College of New York, which is a app that was designed to help people with visual impairments navigate through buildings. So we like the idea of the smartphone app helping people. So we took that and tried to incorporate that as well. And then this one was very similar, and we believe that it would a very good like benchmark to go on is Be Notified from the University of Alabama, which is a mobile location-based scheduling, messaging, and alerts app between a worker and a job coach, which is very similar to us. This project was more based on people using it in a day-to-day application, while ours is more emphasized during work hours.
So the bUDDY system comprises of three main parts: the physical bUDDY device that was built by our hardware team, or was supposed to be built, but coronavirus, the bUDDY web application, and the bUDDY database that the web application uses. Here's a diagram that's basically the overall structure of our bUDDY system. So the database is filled with the information that is used by the web application and the manager uses the web application to send data to the bUDDY device, which then displays that on the bUDDY device, and using text to speech relays it to the bUDDY user, since many of the people that YAI support cannot read. We need like it being uh, iterated, spoken to them is a big part of it. They can press complete task. It will then send that to the web application and let the manager know that the task was complete and that they're ready for another task.
So our related theory, while designing and developing our bUDDY device, circuit analysis was essential to determine necessary values for components such as resistors and capacitors. So while designing each module and the connections of these modules to our whole device, pre-existing diagrams and formulas were used to give us an idea of how to develop our own functional circuits. Based on the pre-existing figures and work that we used, we were able to develop our own designs, which we were able to actually use for the device. And a few of the equations and formulas that we really used and focused on were the simple Ohm's law equation and capacitance equations to figure out the values for those capacitors and resistors and other pieces that we used in the design. Hardware iterations, updates to the existing modules were to create more secure circuits, like added diodes and op-amp amplifier to ensure quality. There were several iterations used for the touchscreen display and the battery. At first, for the touchscreen display, we weren't sure which size screen we were going to use and simple things like that. So we had to go back and change our original designs to eventually decide on which pieces we were going to use, which I'll get into more later. After the COVID-19 outbreak, we also added 2 new modules and more updates to the existing modules. And that's just to better adapt the needs and to really assist the individuals that we work with. And this is to of course make it easier for them to use and to create more security. And then we also decided to add a GPS module to help locate whether if a device gets lost or if a worker gets lost or whatever. So. Now getting into the hardware modules themselves. The first one that we'll get into is the Raspberry Pi 4 Model B. This computing chip had a 1.5 gigahertz clock speed processor, a CPU sporting a Broadcom BCM2711, a quad-core Cortex A72, with 64 bits SoC at 1.5 gigahertz, and then a SD-RAM of 4 gigabytes, LPDDR4 3200, and another key component of this Raspberry Pi 4 model is that it had a built-in Wi-Fi sensor, which is really essential because the communication that we decided to use was Wi-Fi. So it was really important to have that in there. And it also had USB connections and connections to HDMI as well. Moving on to the next one, we have the 5-inch DSi touchscreen. Like I said earlier, we weren't really sure which size would fit best, but after going through it a couple of times, we decided on the 5-inch. It uses a DSi interface to connect the Raspberry Pi board, a refresh frequency of 60 hertz. The resolution is right there. 5-finger capacitive touch, which is really key because you have to be able to, it has to be sensitive and really accurate with the touch. No driver is needed, which is really beneficial to our design. It has strong anti-interference, ultra low power, and it has the automatic sleep, so it's a really efficient screen compared to other touchscreens that we looked at. Next is the GPS module. This module really fit our project because of its high sensitivity and low power consumption. It has miniaturization, which is extremely high tracking sensitivity, greatly expanded its position of the coverage. There's high precision positioning, while the ordinary GPS receiver module cannot locate certain areas, such as in crowded urban skies or crowded environments. And it's also highly sensitive, has small static drift and low power and lightweight volume. Next is the Switchcraft 3.5 millimeter right angle female mono audio connector terminal. This is the audio jack connector. This was a pretty simple selection. There are a lot of other ones that we could have chosen, but based on the key features, the mono jack, right angle vertical, it's threaded, and the installation resistance. I mean, those are all important factors that we considered, but selecting this terminal was fairly easy. Now we get into our fingerprint scanner. Once again, this is something we added after the COVID-19 outbreak. The implementation of this fingerprint scanner is beneficial for security and accessibility purposes. This makes it just easier for the users to be able to sign in and identify themselves in the system. And it also makes the system a little more secure using biometrics. This will lead to false discrepancies, or less discrepancies and less false sign-ins. The required accessories that will be going with it is the fingerprint sensor, the serial USB converter with 3.5 or 3.3 volts and 5 volts connection, and then female to female jumper wires. Next is just a simple audio control potentiometer. This is used, as I said, to control audio, and it is a 9 millimeter side adjusted insulator shaft rotary potentiometer. This would just allow the user to twist and decide which volume they want their audio coming out of, since we want it to be able to do text to speech, which is important since a lot of the users will not be able to read. And then a few other of the hardware modules, just simple. We had the audio amplifier with internal gain, and a switch on-off switch, 100 ohm resistor, and then 2 capacitors as well. And then we also had a stereo jack, the potentiometer, which was already listed, the audio connector, and the rechargeable batteries.
All right, so to continue on after Peter explained the different components we were using for our schematics and our circuits, we can go into just real quickly the different modules we have. The switch button module is shown right here. How to simply use a simple resistor, which should be a 10K instead of 100K, and a switch. A simple switch is connected to a 3.3 volt pin in the Raspberry Pi and connected to a GPIO pin to show when the button's being pressed. This is the audio module, which is just the initial iteration of the audio module. It's just a simple potentiometer to show a speaker, which is the audio, which is the Adafruit on the top, and then the Nutric is another audio jack, which was explained before by Peter. And this is the next iteration of it, where we have an audio jack coming from the Raspberry Pi into a LM386 op amp, which is used to amplify the sound quality, and the circuit itself also helps reduce distortion by using the C capacitor at the bottom of the circuit. And now this is a simple GPS module, which needs no extra circuitry, including resistors or capacitors. It's just connecting to 4 pins on the Raspberry Pi, a 3.3 volt pin, a RX GPIO pin, a TX GPIO pin, and the ground. This is the battery module, which showcases 2 diodes to stop backflow of current. The V plus and VI of the circuit explains that it shows the AC power wall power outlet, and the battery called BT is just a battery for the voltage, the DC current of voltage, which is the actual rechargeable batteries we plan on using during the project. And this is just the next iteration of it. We use this time using a voltage regulator through the Raspberry Pi that helps use a wide range of voltages for these circuits. This is just another. This is the example of a similar to the GPS module, which is it just doesn't use any extra circuitry, and it's for the fingerprint scanner we plan on using for security and access. This is the first iteration of all of the overall circuit, which much of it is different. It had originally only an LED circuit and a display. And this is the final overall circuitry that we have, which includes everything that we just talked about in one big circuit. This is a simulation of the button module that we did in PSpice. When the closed switch is happening, you can see that the voltage goes across the entire circuit, and the open switch clearly doesn't show that there's no voltage at the end of the circuit. And this is the battery module showing that of how the current would flow throughout the circuit from the AC circuit and the DC circuit and the DC battery would flow.
Okay, so for the software design and implementations, we involved a database as one of our main components, and it's just basically 6 tables that we designed that we believe we needed in order to ensure that we have all the proper fields and elements necessary to have our buddy system be effective. So just a few of them, the status table to indicate the busyness status of the user, a general employee tab to keep track of all the employees, and then to direct from those, it's the buddy user would be one table, and then the admin or the boss of the person in charge. So basically, the admin would send out a task to the activity page. The activity page would send it to the assignment, which is accessed by the user on the user end of the buddy system, and then the user would receive the task and be able to hear an audio file playing the activity description of the task, and they would be able to replay the task if needed, and just have it there in case they can read things of that nature. So we just had some performance iterations on the database. Originally, our database was only 5 tables, and we had like less of a description on what each table connected to each other. So we just expanded on it a bit. Some additional things are just changing up the employee table, the user table a bit, adding a status table directly, enhancing the assignment and activity tables to further represent what we wanted. So the assignment, we added the activity ID to it and the activity descriptions so that it'd be able to directly read off just from the assignment table what the activity that was assigned to the user would be. And just, some more of the reason for the iterations, as I said before, being able to change the status, change some of the elements with the employee name instead of being a double element is now a single element. And just removed some of the additional features that we believe are necessary, such as there was a role ID in the previous iteration of the database. We just felt that was unnecessary because there was no reason to keep track of a role ID and a task ID, which was another thing we had in there. And then the text-to-speech we had many more iterations than this. We had originally we had an audio file player. So we believe that if we had like an audio file that would be able to play.
We're running out of time, please. Respect the timing. We're running out of time. Thank you very much.
It's just okay. Yeah, so it's just text-to-speech and then the website.
Our web application is built on a Python framework called Django. Django basically takes Python code, CSS, HTML, and turns into a web application, and we integrated it with an SQLite 3 database to hold our data. And next. So the website started, or the web application started off as just a on a server. That's how we got what you see in the bottom right hand corner.
And then just the testing results and stuff. So it's the unit testing for the hardware. We just had the application test, and we had the file audio file code, and then we just had it implementing into it. So there's just some tests we had with it for the unit testing, just making sure everything worked. The integration test, we wanted to make sure the database connected and that the audio file connected to the system. We had an error the first time with the audio file player, but after some iterations, we were able to fix it up and allow it to integrate. And then the acceptance test, we had the similar, just the web code implementation, the new one we had, and just like additional code we had implement into the website.
For hardware, we had just the still overview of all the unit tests. For hardware, for the actual hardware we have, we only have the Raspberry Pi board and the touchscreen. We were unable to get any of the rest because of the COVID virus. The acceptance tests are just simulations of all the PSpice modules we talked about, of the failures and successes that we had. The integration tests were just attempts of configuring the hardware we received, and there was only a singular failure and one success.
So then just some of the design implementation changes after switching. We had to meet through audio calls, and not being able to physically meet made it harder to sync up the code and stuff like that. So we had to more just distinguish the things. So Tim worked more on the web application as I worked more on the database and text-to-speech software.
And for hardware, we added more modules for complexity and simulated these using PSpice.
And just some for the software for the completion work is we wanted to add a calendar system so that we know if so the user will be able to know if the employee is in or out, and then adding the code for the GPS tracker and the fingerprint scanner, so we could find out if the item was lost, or the bUDDY system was lost or stolen, so we could find it.
And for hardware, we further enhanced the battery design for longer life and more efficiency, and assembled a large quantity of this device so that it could assist workers more effectively.
So then just some of the review challenges and lessons learned is we had no really bright. Yeah, if you want to go. Oh yeah. So then the software team, we just had to basically learn HTML, CSS, and JavaScript, and the Django framework through like Udemy courses and other online references that we use.
For hardware, there were constraints with funding just because it took a while to get the budget from the Create program, and strict deadlines became necessary. And we also had to learn all the software needed to create the circuit designs and simulation.
And then just what needs to be for software. So for the software, we had the GPS software development, so we can ensure the whereabouts to the bUDDY system, the fingerprint scanner, and the quality of life changes.
And for hardware, we just had to complete the bUDDY system by acquiring all the components needed.
And then just some refinements is we were thinking about making a more expensive server with more uptime to allow the bUDDY system to be used anytime, because currently we're using a free version with less allowed uptime.
And for hardware, a custom board would make it much more cost-effective for organizations.
You're taking twice as much time from other students' presentations. This is not acceptable. Please try to complete your presentation. Thank you.
We apologize. Yeah. There's just a bill of materials, then the cost breakdown of just the case and everything like that, LCD display, the batteries and stuff like that. And then this was just a demonstration video, but we don't have to go through that. And then here's just the project schedule, just no-go milestones and things that we set up to make sure that we had everything done. And then just some code standards and constraints using certain IEEE standards and designs, certain transmission protocols, and then ethics issues considered. People using the the project and stuff like that, and just other, IEEE code of ethics, and then just the references. We do apologize about going over length. I guess we lost track of time, and we put additional info that I guess we didn't realize we needed. We do apologize about that.
Are there any questions?
Yes, I have 2 points to make. First one is a good presentation, very good technically. However, we have to learn how to administer our time. So time management is important. That is an issue, a minor problem that is not, just keep in mind. Okay. The second is that once somebody presents, I'm not addressing to your presentation, generally speaking, PowerPoint presentation is not a Word document. So try, please, to present your ideas in bulleted, but try to make it in a way, let's say you can increase the size of fonts and include just few sentences. The tip is not more than 4 sentences in one slide. This is the ideal presentation. So once you keep short sentences, after we can explain verbally what do you mean. That is not only for you, for everyone. This is the successful presentation. Otherwise, it's an outstanding presentation, and thank you very much.
Awesome. We appreciate the feedback, Dr. Yokos.
Thank you.
Thank you.
Thank you.
Okay. Any questions, or is awesome. Thank you, everyone.
Okay, so